Welcome to this video lecture on the subject electronic circuits. So in this lecture we are going to discuss about astable multivibrator. So first of all, let's see what is a multivibrator. So it is a switching circuit. So it consists of two-stage transistor circuit in which the first output is given to the input of second stage. So here the two stages are complementary. So as shown in this diagram, so at once one circuit is switched on and other is off. So like this, these two stages are complementary. So it is continuously on and off is like this, and it consists of several types like astable multivibrator, bistable multivibrator and monostable multivibrator. So let's see the astable multivibrator in detail. So astable are also known as the free running oscillator or multivibrator. So it generates these square waves. So we are not giving any external triggering pulse in this circuit. So it consists of two transistors Q1 and Q2 and RC circuit RC1 and R1C1, R2C2 and RC2. So consist of two-stage transistors, and the important point is that it consists of no stable state. It means it is quasi-stable state because this does not have any stable state. So one stage will be moved to another quasi-stable state. Continuously it goes on like this, so it is a half stable state. So its states is changing from on and off, on to off. And next is the working of this stable multivibrator. So it switches back and forth from one stage to other, so remaining in each state for a time depending upon the discharging of a capacitive circuit. When the supply voltage is applied, one transistor will conduct more than the other due to some circuit imbalance. So how it happens like this? Let us assume that Q1 is conducting, that is first transistor is conducting and the Q2 is cut off. So then VC1, that is output of the Q1, is equal to VC saturation and approximately 0 volt, and VC2, it is output of second transistor, which is equal to VCC, and at this instant C1 charges exponentially with time constant R1C1. So first circuit capacitor is charges towards the supply, and correspondingly VB2, that is base of the second transistor, increases because these two are coupled. So when it crosses cut-in voltage, second transistor starts conducting, and it falls to VCE saturation. Also VB1 falls due to capacitive coupling. So it driving Q1 into off state. When wave Q1 is off and Q2 is on, the voltage VB1 increases exponentially with time constant R2C2. So therefore now Q1 is on and Q2 is cut off. Now the voltage levels are given like this. So when Q2 transistor, now second stage of transistor is on. So VC2, which is output of the second transistor, permits the discharging of capacitor C2, so that Q1 is off now. So the rising voltage feeds back to the base of Q2, turning it on. So this process is said to be regenerative. So here the time period calculation for this circuit. So on time for the transistor 2 is 0.693 R2C2. Similarly, on time for transistor 1 is 0.693 R1C1. So the total time period is 0.69 into R1C1 plus R2C2. When we assume the values are equal, R1 and equal to R2 and C1 equal to C2, we get a symmetrical multivibrator. So which is total time period is 1.386 RC. So the frequencies can be calculated by 1 by T. So let's see the applications of this astable multivibrator. So it is used as a square wave generator, voltage to frequency converter. So it is also used for the production of harmonic frequencies of higher order, and it is used for the construction of digital voltmeter and SMPS, and it is operated as an oscillator over audio and radio frequencies. So let's take the assessment. What is a square wave generator? It is a stable multivibrator, and a stable circuit acts as an oscillator because it generates square waveforms. So thank you for listening this lecture.